GCSE bounds, a very easy question to get right, but also one to lose marks on very quickly because there's a few places it could trip you up. So let's read the question. A race is measured, okay, so we have a distance of 10.6 kilometers to the nearest kilometer. We are running a time of 31 minutes and 48 seconds to the nearest second. We want to find the average speed in v kilometers per hour. So there's three things I want us to look out for. Firstly, we got this bound here, we need to correct. We also have this in minutes and seconds and this in seconds. And then we also have a different unit here altogether. So this is what I'm going to look out for later in the question. The first thing we want to do instinctively is to work out our bounds. I'll put a lower bounds for both these things. You may need it, you may not need it, but I can guarantee it will be a mark on the mark scheme. So we will write 10.6 in the middle of our two inequality signs and write the lower bound and the upper bound. Now if you forget, you just half the rounding, so 1 goes to 0.5 and then add or subtract it. So this is 10.55 and 10.65. So the reason our inequality sounds like this is because 10.65 actually rounds to 10.7 and anything just below it, so 10.6499 will round to 10.6, whereas this is actually true. We'll do the same for this now, but I'm going to convert 31 minutes and 48 seconds into seconds, which is 1908. And again, half the one, which is 0.5, giving us 1908.5 and 1907.5. So this is distance in kilometers. This is time in seconds. So we want to find average speed. So we know speed is distance over time, and average speed is just basically another way of saying we want to find the distance of the whole thing divided by time of the whole race. Okay, but why are we considering bounds? Well, we need to break this up into two separate bits. The first thing is S max, which is the maximum speed Sam could have run. And look, it might sound very intuitive when I give this example, but if we take 20 as our numerator and 2 as our denominator, we get a speed of 10. Whereas if we have 20 as our numerator and 4 as a denominator, we get a speed of 5. So, the bigger the numerator, the smaller the denominator, the larger our speed will be. I know it sounds really easy right now, but when you're in an exam and you might get stuck, it's always helpful to go back to the basics, okay? So, to find S max, we're going to do this divided by this, which is 10.65 over 1907.5. Okay, so we're doing kilometers divided by seconds. We need to divide by hours. The reason I didn't convert this sooner is because to convert seconds into hours, we need to divide by 360. And without even putting this on the calculator, I know it's going to give me a horrible answer. So instead, I'm just going to do it in one go. So 10.65 over 1907.5 divided by 360 gives us 2.0099. 2.00996. Okay. Now S minimum, the exact opposite. We want to minimize our numerator, so take our lower bound, and maximize our denominator. So exact same process, we'll write it out, divide by 360, get an answer, and I'll just skip this for you guys. Okay, and our answer of 1.99004. So, we go back to the question. The average speed in this race is v kilometers per hour. Consider bounds to calculate v. So we now have the minimum speed, we have the maximum speed, it could have been, so now we just want the average of the two. So we do 2.00996 plus 1.99004 equals divided by 2, and we get the average speed to to equal 2 kilometers per hour. So quite a slow runner, but the answer does make sense. They're never going to give you a question where like Sam's running at 20 kilometers per hour. Though this is basically walking speed, at least it makes sense. So I hope this helps you guys. If you have any questions, let me know. But if you're going to take anything away from this, I want it to be this. Look at the working. Everything's well labeled, everything's easily positioned. And remember, it was a 5 marker. 1, 2, 3, 4, 5. It is as simple as that when it comes to GCSE maths. 5 marks, 5 lines. Let me know what you thought of this question and save it to have a go at it next time for yourself.